Hello and welcome to this art tutorial. Here we are at the final round of regression with our final regression model, random forest regression. In the previous section we saw the decision tree regression model, so if now the decision tree regression doesn't have any secret for you, then you will perfectly understand random forest regression. Because a random forest is just a team of decision trees, each one making some predictions of your dependent variable, and the ultimate prediction of the random forest itself is simply the average of the different predictions of all the different trees in the forest. And actually at the end of the previous section about decision trees, I asked you an enigma. The enigma was, knowing the result we got with one tree, what would be the result with 10 trees or 100 trees or 500 trees in terms of visualization and in terms of prediction. So I hope that after watching the intuition tutorial made by Kirill, you actually asked yourself this question and try to predict what's going to happen here with random forest regression. So let's find out about that. We're going to build our random forest regression model and see what happens. So let's do it. We're going to start by selecting the right folder as a working directory. So it's in part 2 regression. And here is the final regression model we were building, random forest regression. So let's go inside. And that's the right folder we want to set as a working directory with the position salary CSV file. So let's click on this More button and set as working directory. All good. And now let's take our regression template to build this model efficiently. So we're actually going to take everything from here to the bottom, but we will only include this code section to visualize the regression model result, because you understood that the decision tree regression model is a non-continuous regression model, and since random forest is a combination of decision trees, then it's a combination of non-continuous regression model, and intuitively we can guess that the random forest regression model is not going to be continuous either. So since this code doesn't work for non-continuous regression model, we will actually use this one that works perfectly for it. So I'm going to copy this, paste that here, and remove this section that is non-appropriate for non-continuous regression models. Here we go, and now the template is ready. Let's change the basics. Let's replace here regression model by random forest regression, visualizing the random forest regression results and fitting random forest regression to our dataset. Okay, great. So now let's build a model, which is in this section here. So let's remove this, and as usual we're going to import the right library for the job and then use a function to build our random forest regressor. So the package we're going to import is called random forest. So for those of you who don't have the package installed in your packages here, well, you can check it out. Mine is already installed because I used it before, but I'm going to write this line here for those of you who need to install it. So install.packages, parenthesis, and in quotes, random. So no capital R, but then capital F-O-R-S-T. All right, random forest. And so I'm not going to install it because mine is already installed. So I'm going to put that in comment. But if you want to install it, you just need to select this line as I just did and press Command and Control plus Enter to execute it. And this will install the package properly. But here I'm going to put it in comment by pressing Command plus Shift plus C. Here we go. And now what we have to do is to add this, library random forest to actually automatically select the box here to import automatically the random forest package when we execute the whole code or the section. So that's important. And now time to build the regressor. So let's do it. We're going to call regressor as usual to keep things simple, then equals. And now the function that we're going to use is also random forest, written the same. And so now let's add some parentheses. And now let's press F1 to have a look at the arguments. Okay, so the arguments are here, and the first argument is data. But as you can see, it specifies that it's an optional data frame, and we could use this argument to build our regressor, but we're going to use the main arguments to specify, the independent variables on one side and the dependent variable on another side. And to do this, we're going to use these two arguments, x and y. So x will contain the matrix of features, that is the independent variables, and y will contain the dependent variable vector, that is the salary column. So let's first input these two arguments. So the first argument is x equals, and so we have several ways to take our independent variables. So one of the ways is to take our data set here and then choose the right columns of the independent variables. And you know our data set is composed of two columns. The first column indexed by 1, which is the independent variable column, and the second column indexed by 2, which is our dependent variable column. So here we need index 1 because we want to take the independent variable. All right, now next argument. The next argument is y, the dependent variable vector. And now, as you can see, y is expected to be a response vector. It's actually a vector. And here it's expected to have a data frame. So by using this one index into brackets here, I actually import a data frame. But here, to get a vector, I actually need to use another trick, another technique, which is, to use the $sign and then the name of the column, which is, of course, salary. And that will give me a vector. So just to recap, this syntax here will give me a data frame because we're taking some sub data frame of our original data frame data set. And here, by using this $sign syntax here, taking dataset $salary, I'm actually taking the salary column of our dataset, but that will make it a vector. And that's exactly what we want because the y argument here is expecting a vector. So we're all good. And now we actually need to input a third argument. Can you guess what that is? For those of you who followed the Python tutorial, well, you will guess what it's going to be. It's actually going to be n3, the number of trees in the forest. Well, of course, we're building a random forest, so it's actually a lot better if we can choose the number of trees that we build in our forest. And it's even better considering the fact that we're going to play around with different number of trees. That is, we're going to start with 10 trees, with a forest of 10 trees, and then, we'll try with a lot more than 10 trees, like 100 trees or 300 trees or 500 trees. So that's why we're going to input the third argument n3, and we're going to start with 10 trees. All right, so let's start with this, and that's all the arguments we need to build our random forest. We only need the independent variables, the dependent variable, and the number of trees. And that will already make a robust random forest regression model. And then we will make it even more robust by adding more trees in the forest. But before we continue, let's set the random factors to something fixed so that we all get the same results. So in Python we use the random state parameter equal to 0. Here we can do the same on R by using the set.seed function. And then in this function we actually input a seed, and we can use whatever seed we want. In Python we usually take 0 or 42, and in R what we like to do is to take either 1, 2, 3 or 1, 2, 3, 4. So let's use this seed to all get the same result, and that will make this tutorial easier to follow if you're coding at the same time. So now we're all good. We're actually all good with the whole code. We don't have anything to replace. The only thing that we'll do now is to try several random forests with several number of trees and look at the visualization results and look at the prediction to see if we're getting close to the supposed 160K per year salary of our new employee that is about to be hired. So let's do it. Let's execute the sections one by one. So let's import the dataset first. Here we go, dataset well imported. We make sure we have our two columns, the independent variable level and the dependent variable salary. Perfect. Now, no need to split the dataset into the training set and the test set. No need to apply feature scaling. And now time to create our first random forest. So let's do this. Let's execute this code section here. And here it is, random forest well created. Perfect. So now it's time to have fun. Would you like to visualize the result first or getting the prediction? Well, first, let's maybe visualize the results because we want to make sure we have the right model and we want to validate it. Because we will try several number of trees. Here we are starting with 10 trees, so we want to see if it looks like a correct model. So I'm going to execute this section. Here we go, and let's see what we'll get. Okay, so first of all, this looks fine. We don't seem to have any problem here. The only thing that we can improve very quickly is actually, those straight lines here that are supposed to be vertical. And to get a better representation of this, we just need to increase the resolution as we did for decision tree regression. So let's add 0.01, that will be sufficient. And let's re-execute this. And now much better. It almost looks like it's some vertical straight lines representing better the non-continuity. And so now what can we say? Let's zoom on this plot to have a better look. And now let's interpret. Okay, so the answer to the enigma that I asked you in the previous section and that I was asking you again in this tutorial is that we simply get more steps in the stairs. By having several decision trees instead of one decision tree, we have a lot more steps in the stairs than what we had with one decision tree. And therefore we have a lot more of splits of the whole range of levels and therefore a lot more intervals of the different levels. So each straight horizontal line here, separated by these vertical lines, are one interval that is one split. And the fact that we get more steps in the stairs is actually quite intuitive because, if we get, for example, this prediction here for the 6.5 level, well, what happened for this prediction is that we had 10 trees voting on which step the salary of the 6.5 level position would be, and then the random forest took the average of all the different predictions of the salary of the 6.5 level made by all the different trees in the forest. And for example, if we take the 4th position level, 10 votes were made. Each of these 10 votes correspond to one prediction of the level 4 salary made by each one of those 10 trees. And then the random forest took the average of these 10 predictions, and this average is nothing else than the prediction of the level 4 salary made by the random forest itself. And so we get more steps because simply the whole range of levels is split into more intervals. And that is because the random forest is calculating many different averages of its decision trees predictions in each of these intervals. So that's what happened. It's quite intuitive. However, there is something important to point out here is that if we add a lot more trees in our random forest, well, it doesn't mean we'll get a lot more steps in the stairs. Because the more you add some trees, the more the average of the different predictions made by the trees is converging to the same average. This is based on the same technique, entropy and information gain. So the more you add trees, the more the average of these votes will converge to the same ultimate average. And therefore it will converge to some certain shape of stairs here. So that's important to visualize this as well. And now, since we have our intuition of the visualization of the random forest regression in 1D, let's see what happens with the prediction. So let's see what prediction we get. Remember that this employee said that its previous salary was 160K. And now let's see what says a random forest composed of 10 trees. So let's execute that. And it says that a previous salary was $141,000. So that's actually a very dangerous prediction because we are way below the 160K salary that this new employee said to have in its previous company. So if we trust this prediction, we would actually think this employee is bluffing. But no worries, we will not stop here. Right now we're going to try a random forest with a lot more than 10 trees. So let's pick, for example, 100 trees and let's see what we'll get. So I'm going to rebuild the model. Here we go. And now let's look at the graphic results. And as I was telling you, we don't get much more steps in this plot of our new random forest regression. We multiplied our number of trees by 10, but the number of steps was definitely not multiplied by 10. If we compare, we can compare that very quickly. This is the previous plot, and this is the new one. 10 trees, 100 trees. We can see that we have maybe a little more steps, but definitely not 10 times the previous steps. So the reason for this, the explanation, is related to this convergence idea that I talked to you about. And so what changes here with 100 trees in terms of the plot is not the number of steps that was increased, but a better choice, a better location of the steps in the stairs with respect to our salary axis. That means that maybe the steps are better located to make our ultimate predictions of the salaries of each of our level from 1 to 10 incremented by 0.1. So to check that out, we simply need to make our final prediction to predict the salary of this 6.5 level. So let's recap. The employee is saying 160K. Our random forest with 10 trees said 141K. And now let's see what say our random forest with 100 trees. Execute. And now it says 166K. So much better. We're getting close to the supposed real salary of 160K, and besides, we're now actually on the good side of the negotiation because we would no longer think that this employee is bluffing. So, since the prediction seems to be improving as we increase the number of trees, let's actually try with 500 trees. So that's a huge forest we have now, so let's execute this to build our new huge forest of 500 trees. Here we go, new forest created. Let's have a quick look at the visualization plot results, but it's going to be the same thing. We will not get a lot of more stairs, maybe a little more. Well, actually, let's check it out. Well, definitely not. We seem to have the same number of steps in the stairs, but as I was telling you, each of the steps in the stairs might actually be better located to make each ultimate prediction of the salaries for each of the 10 levels here. So the best way to check that out is actually to get our ultimate prediction of the salary of this 6.5 level, and let's check it out. Let's see if we get a better prediction than 166k. Executing, and right in the spot. We hit the bullseye with 160,458 predicted salary. So awesome job that this random forest with 500 trees just did here, because it predicted almost the same salary as the supposed 160k salary that this future employee said to have in its previous company. And actually so far, before we made this random forest with 500 trees, the best model that made the closest prediction to this 160k salary was the polynomial regression model, and now the random forest regression is beating the polynomial regression model, because now we get a prediction that is almost the same as the real value. So right in the spot, congratulations, we actually made our final model. And now I just want to conclude this tutorial by making this transition to one of our future parts, which is actually part 10. In part 10 we will build some ensemble machine learning models. That is, some models that are a combination of several machine learning models. And in machine learning, these are actually the best models. When you have a team of several machine learning models, they can actually make an awesome prediction, because unless we have an Einstein machine learning model in our combination of machine learning models that is the only model to be right, well, you're more likely to get the correct prediction with 10 machine learning models predicting the same thing than with just one model. So that's actually what we did here. Well, we had a team of same machine learning models, which were decision tree regression models, but in the future we'll make a team of different machine learning models. So that's going to be very fun, that's going to be very powerful as well, and I look forward to getting there with you. So now I'm telling you congratulations for two things. First, for building this very powerful regression model, the random forest regression model, and second, for having built all our regression models. We built some linear regression models, some nonlinear regression models, some nonlinear non-continuous regression models, and some nonlinear non-continuous ensemble regression model. So congratulations, you're definitely on your way to becoming some experts in machine learning, but wait for what's coming next. So speaking of what's coming next, I look forward to seeing you in the next sections or next parts, and until then, enjoy machine learning!